All right, guys, here we are with the last video for this section. We're going to talk about what's called the power of a test because researchers often are doing these types of significance tests because they want to find convincing evidence for the alternative hypothesis. And you might be asking, like, why? Well, the alternative states a claim about the population parameter that they believe, suspect, worry, or hope is true. So, for example, if a drug manufacturer claims that fewer than 10% of the people who take a drug will experience nausea, well, then they want to carry out a test where the null is zero point 0.1 and the alternative is less than zero point 0.1, where P represents the true proportion of patients like the ones in the study who would experience nausea. Now, um, suppose that the true proportion of patients that experience nausea after taking the new drug is actually 0.08. This means that the alternative hypothesis, where P was less than zero point 0.1, is actually true. So researchers would make a correct conclusion if they found convincing evidence that P was less than zero point 0.1. But if they failed to find convincing evidence that P was less than zero point 0.1, they would make a type 2 error. And so this begs the question, how likely is a significance test to avoid a type 2 error in this kind of situation? So this is what is referred to as the power of a test. The power of a test is the probability that the test will find convincing evidence for the alternative when a specific alternative value is the of the parameter is true. So the p-value um, is a conditional probability, and so is the power of a test. It's the probability of rejecting the null given that the parameter is equal to whatever the specific alternative value is. In other words, the power is the probability that we find convincing evidence that the alternative hypothesis is true, given that the alternative really is true. And then to interpret the probability, we just interpret that conditional probability in the context of the situation. So one of the things that's beneficial is, or that we like to talk about, is is relating power in a type 2 error. So the power of a test to detect a specific alternative parameter value is related to the probability of a type 2 error for that alternative. So the power is equal to 1 minus the probability of a type 2 error. And you could rearrange that equation and get the probability of a type 2 error is 1 minus the power. So increasing the power of a significance test, we can do that in a number of ways. So when the null is false and the alternative is true, a significance test based on a random sample of size n and significance level alpha will have greater power and a smaller probability of making a type 2 error when, well, the sample size is larger or the significance level alpha is larger, or the null and alternative parameter values are further apart, or the standard error of the statistic is smaller. Okay? So those are the four ways that we're going to talk about here. So let's look at an example here with the potato chip problem. So same context we've been using for the potato chips. I'm not going to read all through it. Um, let's just go to the last line there. In one shipment, 11% of the potatoes have blemishes. In this case, the power of the producer's significance test is 0.764. So we're going to do a couple things here. We're going to interpret that value. Now, we're not really going to talk about how to actually calculate the power of a test, but interpreting it is very important. So if 11% of the potatoes in this shipment have blemishes, there is a 0.0764 probability that the producer will find convincing evidence for the alternative where P is uh, greater than 0.08. Okay. Now, how will the power change if the producer uses the 0.01 significance level instead of 0.05? Well, here, based on what we've just previously said, the power of the test will decrease, decreasing the significance level from 0.05 to 0.01 makes it harder to reject null when the alternative is true. Uh, ho ho. Okay. All right. So if we decrease the significance level from 0.05 to 0.01, okay, then it's going to make it harder to reject the null when the alternative is true. So part C, how will the power change if the producer uses 1,000 for his sample size instead of 500? Now, assume the 10% condition is still going to hold. This will increase the power of the test, increasing the sample size from 500 to 1,000 gives more information about the population proportion P. Okay, so that kind of intuitively should make sense. If you have a bigger sample, then you have more information essentially to more information about the population. So in another shipment, only about 10% of the potatoes have blemishes. Assuming the producer selects a random sample of 500 and uses the same significance level from the beginning, how will the power compare to this shipment with the 11% blemished potatoes? So this will decrease the power, or the power will decrease. This is because it's harder to detect a smaller difference between the null and alternative parameter values. So remember, 0.08 was the null. In the first shipment, we had 11% with blemishes, so that was a 0.03 difference. Okay, in the second shipment, you had a 0.1% amount of blemishes, and so that would be a 0.2 difference, okay? So even though um, the difference is it's a small change in the difference, um, it's still the difference is smaller, so it makes it harder to detect that difference between the null and alternative because those values are closer. Okay, guys, that's it for this video. We're going to wrap it up. Make sure if you reach out if you have any questions. Take care.